Okay, so good morning. I'm going to go over a lot of these quiz questions. I just want to make sure that you have a good understanding of what you missed. Remember that in the gradebook under comments, I listed every problem that you got wrong. So make sure you check that out. I think I only had one person maybe get them all right. So I would check that out. Make sure you look through this. You can fast forward if you want to get to the problems that you need to see, okay? So just so you know, on number 1, if two triangles are similar but not congruent, then the ratio of their areas is the same as the ratio of their perimeters. That would be never, because whatever the perimeter ratio is, you have to square that to get the area ratio, and the only way that they would be the same is if it was 1 to 1, but it would only have a scale factor of 1 to 1 if they were congruent. So that one is never going to work, okay? Number 2 is sometimes, because different numbers plugged in could get you to 35 square centimeters. So the area of a rectangle is 7 and 5 make 35, but so do 35 and 1. Obviously, you could throw some decimals in there, so that one's going to be sometimes. And then this last one, if the radius of the circle is doubled, then the area is doubled. This one is also never. Just a way to kind of do that is to pick a number for your radius. And so like I picked, okay, a radius of 2 and a radius of 4. So we have pi times 2 squared compared to pi times 4 squared. This is going to be 4 pi. This is going to be 16 pi. Whoops, sorry. And obviously that's way more than doubled. Okay, so if you're ever kind of stumped on these, don't be afraid to pick some numbers, plug them in, see what happens. Okay, my guess is if you messed up some of these, like especially like 6 and 8, then you probably were making almost the same mistake throughout the whole thing. I am going to go a little bit fast so this video isn't super long. And I may not crank out every number for you, but I am going to set these up. So make sure you check your setup, okay? So this is a triangle. Area for a triangle is 1/2 base times height. The base on this one is very clear. It's right here. It's 24, so that's easy. But the height, we don't know. The height has to be perpendicular to the base. So it has to be this segment right here. And because this is isosceles, obviously I can draw this in. And when I do draw that in, it's going to take this 24 and these are going to be congruent. So it's going to make it 12. Okay, so then how would we find our height? Well, you can just do the Pythagorean theorem. 15 squared is h squared plus 12 squared. 225 is h squared plus 144. And you can go about it that way and finish it there. Or you can go, okay, let me divide both of these. If I divided both of these by 3, this would be a 5. That would be a 4. So this is a 3, 4, 5 times 3. So you're going to end up getting 9 for your height. Okay, you're going to plug that in there and you're going to multiply all that out, and this one should have been 108 units squared. Okay, this one has all 4 sides congruent, so we know this is a square. So we got a couple options. You could write base times height, length times width, or side squared, kind of up to you. The length that they gave us though is this hypotenuse. So again, you have options. You do know these are the same, which if you're good at 45, 45, 90s, that because they're the same, it does create a 45, 45, 90, or you could just use your good old Pythagorean theorem. 2x squared is 64, x squared is 32, so x is going to be the square root of 32, and I wouldn't even simplify that because right here, when you plug that in, the square root of 32, and you square it, you're just going to get 32 inches squared. All right, for 6 and 8, as you can see, there are no heights. So this is a parallelogram. So my area is base times height, and I know my base is 22, but I don't have a height. Again, this height has to be perpendicular. So there's my height. What do I know about parallelograms? The opposite sides are congruent. So I do know that this is 6 meters, and this angle right there is 30 degrees. So we have opposite, we have hypotenuse. So I'm going to say that the sine of 30 is h over 6. And you're going to multiply both sides by 6. You're going to get h to be about 3. Now, the other thing that you could do is you're trying to find the short side. So you know that you could use your hypotenuse equals 2 times short. You could do that. So this is, actually I think it should be exactly 3. So that's going to be exactly 3, and this is going to be 66 meters squared. All right, so this one is done the exact same way. So there's a 42. I'm not going to work out this whole problem. So this is a trap. Area is 1/2 times your height times your base 1 plus your base 2. Okay, so again, you got to find the height here using SOHCAHTOA. So it's the sine of 42 is opposite over adjacent. When you multiply both sides by 18 here, you should get h to be about 12.04. That's going to go here. And then your two bases are 24 and 30. And then your final answer on this one should have been about 325.2 centimeters squared. So very similar problems here. If you missed one, you may have missed the other. All right, this has 2 pairs of consecutive congruent sides. So this is a kite. My formula for area of a kite is 1/2 d1 d2. So do I know either diagonal? I do not. Okay, so I know here I can find, so this piece right here is 35. Okay, so I can find this little guy by doing 37 squared is equal to, we'll just call it x, if you will, x squared plus 35 squared. Okay, I'm not going to crank out all that math. You guys, I know you can do that, but you're going to end up getting a 12 for this piece. But that means this piece is 12 as well. So my first diagonal is 12 plus 12, or 12 times 2, which is 24. Now, my other diagonal, I know the bottom piece is 35, but what I do not know now is this top piece. Okay, but now that I know this is 12, these are perpendicular, that's a 30-degree angle. So that's my short side. So this long side is going to be 12 root 3, or again, you can do SOHCAHTOA. So the tangent of 30 is opposite over, call this y, adjacent. And when you crank out the math on that, you're going to get about 20.8, which plugs in right there. So you would add those together, multiply them by 24, divide by 2, and you're going to get 669.4 units squared. All right, 9, and this was shaded. I think we were pretty good on, so I'm going to skip that one for right now. If you do have a specific question on 9, let me know. Okay, 10, find the shaded area. So what I'm going to do is I'm going to take the area of the whole triangle, the big one, the whole thing, take out triangle 1, take out area of rectangle, take out area of triangle 2. So this is going to be 1, this is going to be 2, this is going to be my rectangle. Okay, so this is 1/2 base times height minus base times height. Oop, 1/2 base times height, that's a triangle, minus base times height minus 1/2 base times height. But obviously they have different measurements. So my whole big triangle's base is 18, its height is 13. Triangle 1 up here is an 8 by 6. So I'm going to take out 1/2 of 8 by 6. My rectangle is a 5 by 6, and then my second triangle is 1/2 of, what is this, a 5 by 12. Okay, so we end up with 117 minus 24 minus 30 minus 30, and that'll get us 33 inches squared. Okay, again on 11, again, your height is here and here, and we don't have that, okay? So some people did get confused on this one because they don't give you any angle measures. Okay, so what you have to do to find your height here, if this distance right here is 12, do you see this rectangle kind of in the side of here? This has to be 12. The whole thing is 24, right? But if we take out that 12 from 24, we have 12 units left to deal with. These have to be the same. So you divide that leftover 12 by 2, and this is a 6, and that is a 6. And that's going to end up getting you a height of 8. Now, again, you can do Pythagorean theorem here when you're looking for that 8. It is a 3, 4, 5 multiplied by 2. and then you're going to plug it in to your 1/2 height times b1 plus b2. And final answer here should have been 144 units squared. Okay, find the area and perimeter of the kite shown. I think the area was the biggest issue on this one. So don't forget that, so area of a kite is 1/2 d1 to d2. Don't forget that one of these diagonals is always bisected, and it's the one that connects the two, like in between the two non-congruent sides. So if that's 6, this is 6. So one whole diagonal is 12. Now the other one, I don't know this piece, and I also don't know this piece. So this is going to be two different Pythagorean theorems, okay? So let's call this one x. This one's going to be 10 squared equals x squared plus 6 squared. So 100 is x squared plus 36. So we're going to get 64 is x squared. So that's going to be 8 up top. Plus, we got to get this one. And we have a 12 and a 6. So 12 squared, we'll call this one y, is y squared plus 6 squared. 144 is y squared plus 36. Then we have 108 equals y squared, and y is going to be about 10.4. So that's got to get added to that 8. So when you add those together, multiply them by 12, divide them by 2, you're going to end up with an area of 110, about 110.4 units squared. Okay. 14 was the big issue, because if you don't download the documents, I don't know why it does this sometimes, your altitude was left off. So I did not count this against you, but I do want to go over it. I want to make sure you know how to do it. So the area of an equilateral triangle, so what does that tell me? It tells me all my sides are congruent with an altitude, which is the height, of 5√3. Now, what do we know about equilateral triangles besides their sides are congruent? These angles, all three of them are 60. So you do have a 30, 60, 90 triangle in the middle of there. So what we have to do is we have to do 1/2 base, which we don't know yet, times the height, which is 5√3. So we got to figure out the base. So that you've got some ways to do that. You can use tangent. Tangent of 60 is 5√3 over x, and you can get that number. Now you're going to have to obviously double it to get the whole side, okay? Or you can say my long side, is square root 3 times my short side. So 5√3 equals square root 3 times short. Divide both sides by square root 3. Either way, you should be getting this little length right here to be 5. Now don't forget, this is 5. That's also 5, so the whole thing across is 10. So you do 1/2 of 10 is 5, sorry, 5 times 5√3, so you could have had 25√3 inches squared here, or 43.3. Okay, 15 was pretty good, so I'm just going to go through 16 here real quick, and we can also look at this one. I didn't mean for this to happen, but there's actually a very easy way to do this one where you don't have to use the proportions. So here they give us the area proportion. There's two ways to do this. We know the area has been squared. These side proportions have not been squared. So one way to do it is to square these and set them equal to 18 over 72. I will tell you that takes more work. I think the easier way to do this is to take your area ratio, 18 is to 72, reduce it by 18, and you get 1 is to 4. Now this is the area ratio. So if you want to compare side lengths, you can't use this. You have to use the side or perimeter ratio, which means you would have to square root those to get a side or perimeter ratio of 1 to 2, and then you can just set this up, cross multiply, and solve. I think that's probably the easiest way to do that one. Okay, this one can be done with proportions, but also, I gave you the perimeter. These are parallelograms, so you could have just added 10 minus x plus x minus 2 plus 10 minus x plus x minus 2 equals 16. And then done the same thing over here, okay? And you should get 8 and 3 on these. You obviously can also do the proportion. I think it gives you a system of equations. All right, let me know if you have any more specific questions. I hope this helped. Please make sure you're going over this because obviously these things will show up throughout the rest of the chapter. Thanks.